Hi grade 11s, today's lesson is on the inclination of a line. The inclination of a line is really the angle that the line makes with the positive direction of the x-axis, and it's measured in an anti-clockwise direction. So here we have our line, there's the x-axis, this is the positive direction of the x-axis, that would be the negative direction. So the angle is here between the line and the positive direction of the x-axis, or any line that is horizontal to the x-axis will yield the same angle. Our gradient is positive here. Note the angle is acute. Here we have a line and the gradient of this line is negative, and note that the angle is greater than 90 but less than 180. So here we have an obtuse angle. This is called the inclination of the line, this angle. And normally it's referred to as theta, but it can actually have any letter there. But in our explanations you will see we refer to it as theta. So m is the gradient. And so if you want to find the inclination of a line, you need the gradient. And tan theta is equal to m, where this should be where theta is an element between 0 and 180. So let me just change that and let me put theta in there. Let's find theta. Theta is an element, and theta is between 0 and 180 degrees. If m, which is the gradient, is positive or equal to 0, then theta would be obtained by saying arctan of the gradient. Remember, that is my formula I will use, and I'm going to explain where tan theta equal to m comes from. And so to find the angle, we always use the second function, tan, which yields this arctan of m, and you'll get an acute angle. However, if the gradient is negative, as in this case, a negative gradient, when I work out theta, and I'll say arctan of m of the gradient, I will have to add 180 degrees in order to get the obtuse angle. And let me explain where does this come from, that tan theta is equal to m. So here's a line here, and if I work out the gradient of this line, we know it's the change in the y over the change in the x, and we can take any 2 points of the line and we'll get the same gradient. Because remember, gradient is a ratio, the change in the y over the corresponding change in the x. And here you see I've got theta would be my inclination, the angle between the line, the positive direction of the x-axis. But of course I can draw any line horizontal to the x-axis. And then can you see these would be corresponding angles, so that's also theta. So whether I work with it here or whether I work with it there, I'm still talking about the inclination of a line. And so let's work with it here, only because my triangle that I've got, my right angle triangle that I've drawn here, is much bigger. And so now this here, the horizontal here would be your change in your x. So let me just move this here. That would be the change in the two x values. And of course the vertical would be the change in my y values. So if you look at this right angle triangle here, then you will see that the tan of this angle here, what is tan defined as? The opposite over the adjacent. And what is the opposite? It's the change in the y. What's the adjacent? The change in the x. So therefore tan theta is equal to m, and that's where that comes from, that tan theta is equal to m. It's based on the gradient. So in order to find theta, we need the gradient of the line. In fact, if we have theta, we can also work out the gradient of the line. So if I say theta is equal to 30, then I'll say tan of 30 and I'll get an answer, and that would be the gradient of the line. Tan of 45, if it makes a 45-degree angle, tan of 45 is 1, and that would give me my gradient. So this formula can be used both ways. To find the angle, and then I will use second function and the value of the gradient. And if the gradient is negative, then I'm going to add 180 to get the value of my angle. Or it can be used to find the gradient if I have the angle. So let's look at a few examples. In example 1, it says determine the inclination of the given line. So what do we need to find the inclination? The moment they say inclination, you're looking for the angle that the line makes with the horizontal to the x-axis or with the x-axis. Okay. So the gradient of this line is the change in the y of the corresponding change in the x. You can see from the sketch, which is drawn to scale, the change in the y is 1. The change in the x here is 4. And so my gradient is a quarter. Or use the gradient formula. The change in the y, 4 minus 3, over the corresponding change in the x, 6 minus 2, gives you a quarter. So tan, I use my formula, tan theta is equal to m. Therefore, tan theta is equal to a quarter. I use my calculator and I will say second function tan, because that key is always used when you're looking for an angle. Second function tan of quarter, that's m's value, and you'll get 14,04. So that angle there is 14,04. You can see it's not a very steep line, hence the size of the angle. Let's look at example 2. Refer to the sketch and determine the inclination of each of the following lines. So let's look at line AB. You can see this line has a negative gradient. Let's work it out. So it's the change in the two y values, 3 minus 1, over the corresponding change in x, 2 minus 6, which gives you 2 over negative 4, which is negative a half. The gradient is negative. So therefore, tan theta is equal to minus a half. I use my calculator. If I say shift tan of minus half, it's going to result in a negative angle. So you add 180, and therefore theta is 153,43 degrees. So remember, when the gradient is negative, then we're going to add 180. When the gradient is negative, we will say arctan of that gradient plus 180. And that will result in an obtuse angle. Let's look at CD. You can see this is a vertical line. The gradient is undefined. Okay? And therefore theta is 90. So any vertical line, and how do I know it's a vertical line? Besides seeing it in the diagram, it has the same x value. Okay, and if you had to use your gradient formula, you will get 0 on the denominator, which means the gradient is undefined. And when the gradient is undefined, we have a vertical line, and that angle of inclination is 90 degrees. So theta is 90. Let's look at EF, a horizontal line. How do I know it's horizontal? If it's not in the sketch, the y values are the same. So there's no change in the y values. That's a horizontal line. And what's the gradient here? The slope is 0. And the angle that it makes with the positive x-axis is 0. So note, the gradient is 0, therefore the inclination is also 0. Let's look at our third example. Determine the inclination of a straight line, 2y plus 3x equal to 5. Remember, for the inclination of the line, in other words, the angle that the line makes with the positive direction of the x-axis, you need the gradient. Now, you cannot read off the gradient when it's in that form. You need to write it in gradient y-intercept form. In other words, make y the subject. So therefore, we're going to transpose this term here. becomes minus 3x plus 5. Divide both sides by 2, get minus 3 over 2x plus 5 over 2. So my gradient is therefore minus 3 over 2. I have my gradient. Therefore, to find the inclination, I use tan theta is equal to the gradient. I employ my calculator, and I will say shift tan of minus 3 over 2. It will result in a negative angle, but I add 180 to find the obtuse angle. So therefore, the angle that this line makes with the positive direction of the x-axis is 123.69 degrees. Negative gradient, obtuse angle. Let's look at example 4. It says determine the equation of a straight line with an inclination of 135 degrees and passing through the point 32. So I've made a sketch here just to illustrate what it looks like. So it has an inclination of 135 degrees. So that's obviously an obtuse angle. And it passes through the point 32. So remember, to determine the equation of a straight line, all I need is the gradient and a point. So here we have the gradient in this format that says the inclination is 135. So to find the gradient, I say tan of 135. Remember, m is equal to tan theta. So m is equal to tan of 135 degrees. So I'll just tan on my calculator 135 equal to minus 1. So now I have the gradient. It is minus 1 and I have a 0.32. This is x1 and that's y1. So y minus 2 is equal to minus 1, x minus 3. Remove the bracket, negative x plus 3. And now transpose that term, minus 2. Add 2 on both sides. So therefore y is equal to minus x plus 5. Proving again, when the inclination angle is obtuse, then the gradient is negative. So what do we need for inclination of a line? We need to work out the gradient of the line. And then we can determine that angle using tan theta is equal to gradient.